We have a reaction between carbon and sulfur. The system reaches equilibrium at a temperature T in a sealed 2 decimeter container. The Kc value is 9.4 at a temperature T. The first question, 6.1, we're supposed to state Le Chatelier's principle. It says that when the equilibrium in a closed system is disturbed, the system will reinstate a new equilibrium by favoring the reaction that opposes the disturbance. That is Le Chatelier's principle. 6.1. 6.2, on the other hand, at equilibrium, 1 mole of CS2 is present in the container. Calculate the concentration of S present at equilibrium. What is the information we have? We have the Kc is equals to 9.4. We have the number of moles of CS2 at equilibrium. So the number of moles is 1 mole. But we are given the volume. It is said to be 2 decimeter cube. So we can find the concentration of CS2 at equilibrium. So the concentration of CS2 will be equals to the number of moles divided by the volume. This is going to be 1 divided by 2, which is 0.5 moles per decimeter cube. So we have the Kc and we have the concentration of CS2 at equilibrium. How can we possibly find the concentration of S at equilibrium? We can simply say that Kc is equals to the concentration of the products. So that is the concentration of CS2 divided by the concentration of the reactants. On the reaction side, we have carbon and sulfur. But carbon is a solid, so we don't include it in our Kc expression. In the denominator, we are only going to have sulfur to the power 2. Where is the power of 2 coming from? The balancing coefficient. If we go ahead and substitute, we're going to get 9.4 being equals to the concentration of CS2, 0.5 divided by the concentration of S, sulfur squared. So the concentration of sulfur will be equals to 0.5 divided by 9.4. Everything to the power 1 divided by 2. We're taking square roots on both sides. If you put that in your calculator, you're going to get 0.23 moles per decimeter cube as the concentration of sulfur. There we go, 6.2. Let's go ahead and take a look at 6.3. So in 6.3, the volume of the container is now doubled. After a while, a new equilibrium is established. 6.3. How will the amount of sulfur change as this new equilibrium is established? Choose from increase, decrease, or remain the same. Okay, let's take a look at our equation. We have carbon plus 2 atoms of sulfur to give us CS2. Well, our reaction is reversible. What is happening? We are increasing the volume, right? So let's just note that we increase the volume. According to Le Chatelier's principle, if you increase the volume, the system will try to decrease the volume by favoring the reaction that opposes the change. The volume is increased. Increasing the volume decreases the concentration. This decreases the concentration. How can the system react to this change by increasing the concentration? It is going to favor the reaction that leads to more number of moles so that the concentration can increase again. Let's take a look at our reaction. On the right hand side, we have a balancing coefficient of 1 on our gas. And then on the left hand side, on the gas, we have a balancing coefficient of 2. If reverse reaction is favored, that is going to lead to more number of moles, as we have a balancing coefficient of 2 versus 1. So here, the reverse reaction is favored when the volume is doubled. When the reverse reaction is favored, then the amount of sulfur is going to increase. So the answer to 6.3 is increases. We don't have to answer 6.4 because in answering 6.3, we actually addressed it. Let's take a look at 6.5. If the concentration of CS2 changes by x mole per decimeter cube, write down an expression for the equilibrium constant Kc in terms of x. Show all your workings. No simplification or solving for x is required. Let's go ahead and take a look. The Kc is not going to change because in order to change the Kc value, we need to change the temperature, right? So the Kc is still equals to 9.4. The only change that is occurring is with regards to the concentration. Well, let's go ahead and draw our table. There we go. Before we doubled the volume, the concentration of sulfur was 0.23 and the concentration of CS2 was 0.5. When you double the volume, the concentration of sulfur is now going to be equals to 0.23 divided by 2, which is equals to 0.115. On the other hand, the concentration of CS2, 0.5 divided by 2, which will give us 0.25. This is because the volume is being doubled, so the concentration is being halved. So the initial concentration of sulfur, we have 0.115, while the initial concentration of CS2, we have 0.25. We are told that the concentration of CS2 changes by X. In 6.3 and 6.4, we've already explained that the reverse reaction is going to be favored. So this is going to be minus X. The concentration of CS2 is going to decrease by X. While on the other hand, the concentration of CS2 is going to increase by plus 2x. Why plus 2x? The balancing coefficient of sulfur is 2. So that's why we have that there. When I have 0.25 minus x, 0.115 plus 2x. We're going to have Kc being equals to the concentration of CS2 divided by the concentration of sulfur squared. So 9.4 is equals to 0.25 minus x divided by 0.115 plus x squared. This is our Kc expression.